Welcome, scholars. Mr. Sarles here. 5.2, Normal Distributions, day number 2. Okay, take a look at this page. It is ACT test results by every single one of the states in 2017. I have Minnesota highlight. Take a look at this page for a second. Analyze the data. What do you notice? Students in the past have noticed several things. 1. Participation varies a lot. There are quite a few states where the participation is 100%. In Minnesota, all of the students are given an opportunity to take the test for free in their high school setting. Notice in Minnesota, our composite score is not one of the highest. So how are we doing? Well, if you compare us to the states that have 100% participation, Minnesota has the highest average composite score. Colorado, Wisconsin come in next. Okay, scores on the math part of the ACT in Minnesota for 2017 followed an N21.5, 4.5 distribution. Pause for a second. What does that mean? That means distribution is normal, mean 21.5, and standard deviation of 4.5. So moving over one standard deviation, 4.5. 26, add 4.5 more, 30.5. Subtract 4.5, 17. Subtract 4.5, 12.5. Part A. What percent of Minnesota students earned a score between 20 and 25 on the ACT math test? Mr. Kingsbury in the last video showed you how to use the 68, 95, 99.7 rule of thumb. Why can you not use that rule of thumb for this problem? Okay, I shaded in 20, 25 and the area that we're looking for. The reason we can't use the rule of thumb, we are not exact standard deviations over. The 68, 95, 99.7 only work if you're exactly 1, 2, 3 standard deviations from the mean. We need a new tool to find this percent that is shaded when we can't use the rule of thumb. We will use our graphing calculators to estimate this percent. This graph is called the density function. It has a normal shape. When you're trying to add up the areas of all the different slices on this normal graph, it's called cumulate. So we are going to do a normal cumulative density function calculation. And notice I get 4 inputs: lower, upper, mu, and sigma. Lower represents the lower bound of the area I'm looking for. So in this problem, 20. Upper is the upper bound of the shaded region. So in this case, 25. The mean, 21.5. The standard deviation, 4.5. Hit paste. It actually takes that and writes it onto the main screen. Hit enter and it will find the shaded area. Some of the TI-84s do not have that pull-down menu and it will automatically go to the main screen. You make your calculator look just like this. Notice between the numbers are commas. The commas are right here above the 7 key. Okay, showing my work. The proportion of the data that is between 20 and 25 using our Algebra 2 notation equals normal cumulative density function, lower value of 20, upper of 25, mean of 21.5, standard deviation of 4.5. That's how you show your work. Answer 0.4122. Now, final answer to the problem then. 41.22% of all Minnesota students scored between 20 and 25 on the 2017 ACT math test. All right, part B. Same problem. This time, find the percent of students that scored above 30 on the ACT test. Again, I have the mean and standard deviation on my graph. I'm going to shade in the region of interest that we're looking at, so 30 and above. Okay, I'm going to grab my calculator. I'm going to do a normal CDF calculation again. This time my lower bound is 30. My upper bound, well, anything greater than 30. On the ACT test, the highest score you can actually get is a 36. So a lot of kids are tempted to put in 36 for this answer. But this normal distribution theoretically goes on forever. So the true answer for the upper bound is infinity. Our calculator does not have an infinity button. The TI-89s actually do. So on the TI-84, I'm just going to enter a very large number. I'm just going to enter a bunch of nines. I'll get it close to 1,000,000. Okay, mean 21.5, standard deviation 4.5. Paste, main screen, and there is my answer. Okay, let's transfer the information to your note sheet. Probability, x is greater than 30. Normal CDF, 30. Infinity, 21.5, 4.5. Here was our answer. I just went out to 4 decimal places. There are tables in books that typically go out 4 places. That's why I go out that far. Final answer, 2.95% of all Minnesota students scored above 30 on that 2017 ACT math test. Okay, try part C on your own. Pause, come back, see how you did. Okay, percentile rank for someone who got a score of a 27. Step 1, make the normal graph. Step 2, shade in the area of interest. Percentile rank, that represents the percent of people that you actually beat if you got a score of 27. So here's the boundary of 27. You will have beaten all those people to the left. I want to find that area. Normal CDF. This time, graph goes forever to the left. Negative infinity. On my calculator, negative 99999, very large number. Up to 27. So negative infinity up to 27. Mean, standard deviation, there is our percent, our proportion. So final answer, a student who scored a 27 would have a percentile rank of 88.92%. Part D. Lauren earned a score on the ACT that put her in the top 5% of all test takers. What score did she earn? Okay, I'm going to put that information on the graph. I know from the rule of thumb that this little area in this tail would be 2.5%. So Lauren's score is going to be right about here. So I put an X there, and I put the percent in that shaded region. This problem is different than the first 3 we have done. Why? So this problem, we are given the percent, and we have to work backwards to get to the original score. Mathematically, working backwards, the word inverse. Okay, I'm going to go to second distribution on my calculator. This time I want to work backwards on a normal curve. I'm going to hit inverse normal. This one says area, mean, standard deviation. Area in this problem represents percentile. And oftentimes you'll have to make a calculation from your diagram to figure out the percentile. Lauren, 5% beat her, so she actually beat this other 95% of the students. So Lauren's percentile, 0.95. The mean, 21.5. Standard deviation, 4.5. Paste to the main screen, enter. And now it gave me the score that represents this 95%. Okay, let's show our work. So this time, x equals inverse norm, percentile of 0.95, mean, and standard deviation. And there's our answer. So Lauren earned a score of 28.9018 on the 2017 ACT. But the ACT doesn't actually report scores in decimals, so I would predict that she got a score of 29 on the test. Okay, final student, Mark. Mark scored so that this picture down right here represents where his score is. Pause the video for a second, see if you can figure out how to calculate Mark's score. I'm given a percent, and I'm looking for a score, so I'm going to do inverse normal. First thing I need is the percentile. Tricky because a lot of kids think, hey, here's the percent of kids that Mark beat, when in reality, he actually beat all of those kids. So I had the half of the graph over here, which was 50%, and I had the 42.57% that was shaded in over here. So the percentile for Mark is actually 92.57. Plugging into the calculator, inverse norm, percentile, mean, standard deviation, it gives his score of 28. Okay, real life example. Please read through this, pause the video, try to do this on your own without my help. I'll go through the answer when you come back. Actual weight, 33 ounces, so that is my mean. Standard deviation of 0.7 ounces, I counted up and down by 0.7s. What percent of the box contains at least as much soap as the label claims? The label claims 32 ounces. So here's 32. All of these over here contain at least as much as claimed. I'm given a score, asked to find this total area. So I'm going to do a normal cumulative density function calculation. 32 to infinity, mean, standard deviation, there's my answer. 92.34% of the boxes contain at least 32 ounces of soap. Okay, last problem. Pause. Try to do it. Come back. Okay, the key to this problem. We're trying to find what we should claim on the box so that we are telling the truth 99% of the time. So the problem becomes, do I put the bar right here or the bar right here? Look back at the last problem. If I put it at 32 ounces, I was correct 92% of the time. I'm going to actually need to have the bar further this way so I get 99%. Now, normal CDF or inverse normal? I'm given a percent, need to work backwards. So, inverse normal, percentile. This mark right here beats 1%. So my percentile is 0.01. Mean of 32, standard deviation, I get this answer. So we should claim that there are 30.3 ounces of soap in the box, to be accurate at least 99% of the time. I would also give you credit if you rounded to the nearest tenth and did 30.4, but if you did 30.4, you wouldn't quite get 99%, so that's why I rounded down in this case. I wouldn't mark wrong for that, but that is the correct answer. Okay, that is it for day 2. Thanks a lot.